Hello everybody, this is Solartiger. Today is Sunday the 17th of May and this is will be an information video about solar panels and what the numbers on your solar panels relate to. Okay, so this is my windowsill system and this is the 50 watt panel that charges my power box, so I will be using this as an example. Solar panels come in different types. The three main types are monocrystalline, polycrystalline and amorphous. The monocrystalline are the most efficient but also the most expensive. Then just behind are the polycrystalline or multicrystalline as well. They're two names for the same type. They are only slightly less efficient than the monocrystalline panels but are cheaper. And the third type are amorphous panels. These are the dark brown coloured panels. They are much less efficient than the monocrystalline and polycrystalline panels. They are much cheaper and are mainly used to produce small panels that are used to power garden lights and water features and things that don't require a lot of power. So the main types of panel that we use are monocrystalline and polycrystalline. All the panels that I use are monocrystalline. I bought most of them second hand. I bought some second hand and some new, so I will have all monocrystalline panels. Okay, if we look at a typical solar panel, I will be using one example throughout this video. If I can just rest on here. Okay, so this is my 50 watt panel and I will be using this as an example. Okay, on the back of your solar panel there will be a model number. In this case it says PWM-50W. Obviously this is a 50 watt panel and it is monocrystalline. A giveaway of monocrystalline panels are that the cells, this is the back of the panel, but this is a cell. A complete cell is like a square with the corners cut off, and these are monocrystalline panels. This panel has the cells where they've been cut in half, but all monocrystalline panels are, the cells are this shape. Polycrystalline panels have rectangular sections, so that's how to tell. Anyhow, if we come back to the label, it says watts peaks, though it would make more sense if it just said peak watts. So the peak wattage of this panel is 50 watts. Now you'll only get 50 watts under very sunny conditions, and you'll definitely not get 50 watts if you operate your panel indoors, even on a windowsill. So to get 50 watts, your panels must be outside, exposed to the direct sunlight. Okay, next we have the short circuit current. If you connected a piece of wire between the positive and negative terminal and created a short circuit, then the current that would flow in this case is 3.03 amps. In normal conditions you would not do this, but you will use this rating to determine the current capacity of your charge controller. So if you use this panel, you would need a charge controller with a minimum rating of 3 amps. So that's the reason for that. The open circuit voltage of this panel is 22.5 volts. Obviously there's no point of putting your panels outside and not connecting anything to them, but this is the maximum voltage that you would get if you measured with a multimeter. with no load connected. The next rating says optimum operating current, so that's the maximum power current. That's the current that would be provided when the panel was outputting its maximum power. In this case it's 2.78 amps. You'll see that this is less than the short circuit current. Optimum power voltage, or maximum power voltage, in this case 18 volts. And then we have the dimensions of the panel in millimeters. Not all panels have the dimensions written on them. Then we have the weight of the panel in kilograms. In this case 5.1 kilograms. Now the weight of the panel you might find this value useful if you're mounting it on a structure and you want to make sure the structure is strong enough to carry the weight of all your panels. Otherwise this value does not mean a lot. One thing I'll point out is that outside I have two 100 watt panels, and each of these panels weighs 8.5 kilograms, which is easily to carry by themselves, but I mounted two of these panels onto my frame, and once I mounted them together, the combined weight was 17 kilograms, and it was very heavy to manhandle onto the shed roof. So you might think that just getting the biggest panel you can afford might be a good idea, but consider that you have to carry them around or move them, and you might suddenly realize that buying two smaller panels may be a better idea, especially if you have to carry them up a ladder to mount them on a roof or other structure. So weight can be a factor. Sometimes two smaller panels might be a better bet than one very large panel. Anyhow, back to the rating sticker. Okay, now all the values that are named above, other than the dimensions and the weight, are measured under standard test conditions. So all the ratings given on your solar panel label are obtained at standard test conditions, which is AM equals 1.5, irradiance equals 1000 watts per meter squared, and the temperature is 25 degrees Celsius. So what this means is that they measure the values when 1000 watt light is aimed at 1 square meter of solar panel, whilst the temperature of the panel is 25 degrees Celsius, will give you the ratings that are given above. Now that's alright when the solar panel is at 25 degrees Celsius. In the real world, outside, when your solar panels are exposed to the sun, they absorb the sun's radiation, and they also heat up. They get hot. So the temperature is no longer 25 degrees Celsius. And on a bright, hot, sunny day, the temperature can exceed 50, 60 degrees. They can get very, very hot. Now when the solar cells get hot, they actually produce less current. So the hotter they get, the less current they produce. So that means that when you mount your panels, you need sufficient ventilation for them to lose some of the heat. So if air can circulate around the panels, then they can become cooler. And the cooler your solar panels are, the more efficient they are. Now, if the temperature is very cold, i.e. in the winter, but the sky is very clear, then you can, under some circumstances, produce more power than what is given on the rating sticker. So this is just what the values mean on your solar panels. So thank you for watching.